Hello, and today in this lesson we will be learning how to simplify roots and rationalize denominators. Here, for this problem, we have the fourth root of x to the 28 times y to the 16 all over 16. This looks tricky at first, but we can play around with it, and in the next slide you'll see how it becomes easier. With how roots can be rewritten as exponents by just inverting the root number, in this case it's the fourth root, so we can write the whole thing to the 1/4, and we'll see why that's useful. Now with how multiplication is, we can break it up all separately, like we have right here. So in the next slide you'll see why that's useful. We can multiply the exponents together, x to the 28th over 4, y to the 16th over 4, and we can rewrite 16 as 2 to the 4th to make it easier on us, so we'll end up with 2 to the 4 over 4. These are the results of multiplying the 1/4 into the current exponents that are on the numbers. So when we simplify these, x to the 28 over 4 can simplify to x to the 7th, y to the 16 over 4 is just y to the 4th, and 2 to the 4 over 4 is just 2 to the 1, or as we just know, 2. So that would say that our final answer would be x to the 7th times y to the 4 all over 2. And then we'd be done. Although, a tricky thing you have to look out for is if odd exponents are brought outside of even roots, you need to use an absolute value sign. So in this case, we had an x to the 7th result from that, but we had a fourth root that we began with. So we have to make sure to put an absolute value sign on this, because odd roots can give you a negative number, which the previous x to the 28th could not give you, and under an even root that wouldn't be possible. So for the next one, we have the fifth root of 5x to the 6th all over 3z to the 4th. This one looks tricky as well, but we can play around with it and it'll become really easy and apparent. So since we're dealing with the fifth root instead of the fourth root, we're going to go along a similar path, except we want to look for 5s rather than 4s. So over here on the right side, we are multiplying by 3 to the 4 times z to the 1 over 3 to the 4 times z to the 1, because this is all equal to 1. So we're not changing the value of this. We are just changing how it looks. So the goal of this is to combine these two terms to be 3 to the 5 and z to the 5, so that we can easily get them out of this root. So on the next slide, that's what we do. We have everything combined here. And now, similar to the first question we had, we're looking for perfect 5s. So we have 3 to the 5th here, z to the 5th here, and you think we're done, but we actually have an x to the 6 over here. This can be rewritten as x to the 5th times x to the 1, because when you multiply these, you add the exponents together. So we once again have another 5th here. So what we can do here now is bring out those three values, like we do so here. So we have x over 3z times the remaining stuff that we can't get out of the fifth root, which would be the 3 to the 4 and the 5, which we just combine to multiply together to get 405. And there's one x and one z that we cannot get out of there. And thus, we're left with our final answer.